Okay, so next one was number 22. And in number 22, you're firing a bullet, initially going 87 meters per second, through a block of wood that's 4 centimeters wide, and it comes out the other side going 12 meters per second. The mass of the bullet is just a measly 2 grams. And the question first wants to know how much energy was lost as it went through the block, and then it wants to know what was the force that was acting on it. What was the average force that the wood exerted on the bullet. Okay, so first we're going to find E loss. So we write our equation down. Initially it has a speed. Whatever height it has, it doesn't change, so we can call that height 0. No spring. When it comes out on the other side, it has a speed. Still comes out at the same height. No spring, and E lost. And it's this E lost that we're looking for, so we'll take the 1/2 mv f squared over to the other side. So 1/2 mvi squared minus 1/2 mvf squared is going to equal E lost. And now we can fill in our numbers. So E lost will equal 1/2. The mass of the bullet was 2 grams, divide by 1,000, so 0.002 kilograms. And the velocity was 87 meters per second. And remember, when you type that in, it gets squared. Minus 1/2 0.002 kilograms times 12 meters per second squared. And so when you do this, you get an E lost of 7.425 joules. Not that big compared to the roller coasters, but then the bullet's not that big compared to a roller coaster, so that's okay. Okay, so that's the first part. Then you need to remember that E lost is equal to the work done by friction, and work done is F delta D cos theta. So in this case, the F is the force of friction, really, that the wood is putting on the bullet as it goes through. So rearranging this for F, it'll be E lost over delta D cos theta. So our 7.425 joules goes on top, and on the bottom is 4 centimeters. That's how wide the block was, but that's 0.04 of a meter. And the angle is going to be cos of 180, because the bullet's going this way, but the force would be going backward, right? That's why it's slowing down. So 180 degrees in the difference. And so it ends up giving you negative 185, I think, 0.625 newtons. Negative, opposite the direction of the bullet. Okay? Done. One last question from last night, and that was the kid on the slide. So the kid's sitting at the top, not one of those playground bullies that runs up and fires themselves over the top of the side. Kid's patiently sitting at the top, waiting for the kids down below to move, so VI is 0. We don't actually know how high the kid is, because it says the length of the slide. So we know the hypotenuse is 4 meters. We know the angle is 40. So we can find the HI. And we can do that by using, that's opposite, so it would be sine. So sine of 40 is equal to HI over 4 meters. So HI is going to equal 4 meters times the sine of 40. And when you type that into your calculator, you get 2.571 meters. Okay, so we now have our HI. And so the question wants to know how much energy was lost due to friction, and what was the force of friction if at the bottom she's going 3.2 meters per second. Sounds like an exciting slide, doesn't it? 3.2 meters per second. Then again, the kid's 15 kilograms, so that's only 33 pounds. So this kid is like a 3-year-old. So maybe 3.2 meters per second isn't bad for the 3-year-old. All right, so we go to our equation. At the top, there is a speed, there is a height. No speed. There is a height, no spring. At the bottom, there is a speed, no height, no spring, E lost. So you're looking for E lost. So take your speed over. So you'll have E lost is equal to mghi minus 1/2 mvf squared. Fill in your numbers. E lost is equal to 15 kilograms 9.81 meters per second squared. Height was that 2.571 meters we just found, minus 15 kilograms times 3.2 meters per second. Oops, off the sheet, sorry about that. Squared. Okay, so do the math. In the first term, you get 378.345 joules. In the second term, you get 76.8 joules, assuming I typed it in my calculator correctly. And so you get an E loss of 301.545 joules. Okay, so that's how much energy was lost, but they wanted to know friction. So again, you go E lost is equal to work done by friction, which is FFR delta D cos theta. So friction is going to be equal to E lost divided by delta D cos theta, just like in the last question. E lost this time, 301.545 joules. Delta D this time is the length of the slide. It's the 4 meters, because that's the length along which friction is acting. Okay, so 4 meters. And again, the angle is going to be 180 degrees, because the kid's coming down the slide, but friction's acting up the slide. And so when you do this, you'll get a negative 75.386 newtons. Okay, and once again, the negative will mean up slide. Oops, it'd be good if I spelled slide right, because the kid's going down the slide. Okay, and there it is. That's your homework. I will do a separate video for example number 5, okay? So if you want, you can try example number 5 to see how you do, and then watch the video. Okay? Have a good rest of the day.